Okay, it's the 3rd of June. It's almost 3 a.m. and I am out here to show just how small these orb clusters and orbs can be. Okay, what you're looking at is one of those things that turns in the wind. I use it to scare pigeons away from the balcony, and it's only about 6 inches in diameter. And as you can see already, there are a lot of orbs on it, but they're invisible to the naked eye. You can only pick them up with a good camera that has super fine high definition, and it would have to be a camera with a lens of 18 pixels or more. So I'm going to just let it sit there for a second, and I'm at no zoom at all, because it's only about a meter away from me, and let you just get a handle on the movement that's going on. And then I'm going to move just a slight bit closer, and I'll do it like that, little by little, and show you that these orbs down here that are so tiny, you need a microscope to see them, work in the same manner and do exactly the same things as the orbs that make the moon and that make the stars, and the orbs that are in outer space. And the orbs I'm talking about are I don't know how many times larger than these, because these are so small you can't see them. Okay, even I can't see them unless they start to fly around and glow. That's how small they are. Okay, these are like beyond any type of visual potential for any human being, even maybe for most animals. Animals with eyes a lot better than our own. Birds like eagles or hawks, or other animals that have good eyesight, they wouldn't even be able to see these. That's how tiny they are. So here we go. And just move it a little bit at a time. Let you get accustomed to that view and movement. A little more. You can already start to see the general movement and the similarities of the orbs I've shown in just a few last previous videos to what's happening now. You can see that these are cluster organisms, just like the larger ones. So I'm doing this in the dark. And these orbs are like all over the place, and not just on this thing, but in the air, you know, on buildings, on the ground, in the trees, in the water, all over. There's no place that these orbs aren't found, and they're all over the earth, just like this. And there's no organism too small for them to prey on, because they can be smaller than bacteria and prey on organisms that are smaller than that. And they go to like such a small size, just as they go to an infinitely large size in space, they can be infinitely small, either down here or on any other planet or moon, or just about anywhere. Even in space there are small ones like this, because I'm sure that some are being raised in space. They're not all being raised on planets and stars and moons. So you can see how fast they move for the size that they are. This is like thousands of miles an hour, or thousands of kilometers an hour, any way you want to look at it, for the size that these things are, so small and everything. This is really fast movement. And they're not flying right now. Okay, they're right on the I don't know what you call that thing. It's like a little propeller. And this is how fast they move. Right on it. And this is not them in the air. This is how fast they can move along a surface of something. So imagine how fast the larger ones can move along the surface of something. There would be no way of escaping one of these if it was, going to come after you. You couldn't possibly outrun it, even with military jet. It would just catch up to you, even if it was on the ground. it's important to show the difference in the sizes of the orbs, and these are big in comparison to how small they can be. The difference between these and the really, really, really small ones is like the difference between the ones on the moon and these. So there's no place these things can't go, no place they can't reach, and no place small enough for them not to be able to get into. Okay, those dark spots are, I think, a maple leaf that's on the, like a design of a maple leaf, but it's red, so it looks black in the dark. They're not orbs. The orbs I'm talking about are those other little things that are moving around on top of them and all around them. See how they're moving counterclockwise? Now you can see which way they're moving. And you see how they're clustering up into little clusters and all. I'll show you this one down here first, to the bottom right, and then I'll go to the top. I'm just going to raise this a little bit if I can, without shaking the camera. See the thing moving in the wind? That's the little propeller. And these are just like two blades of it. Look how many of them there are. The closer you get, the more you realize the whole thing is covered in these things. Watch, I'll back off a little bit. See them? But the closer you get, you realize that they're all over the thing. Notice the counterclockwise movement. And it's counterclockwise movement going up and down, sideways, all different ways. And this is all like a geometric sequence, because they'll have to be able to make different shapes. This is their learning curve. When they're small like this, they learn geometric patterns. This is exactly what the little ones I had in the jar used to do. I mean, they did everything. They used to vanish, blend in, look like glass, look like something that was outside the jar. A million and one ways of disguising themselves. At times I thought there was nothing in the jar. I had to question myself, did they escape or what, you know? But they were there. Now, the way they go through stages of their evolution and development is they cocoon themselves. Weave sort of like a web and make a cocoon, and they hatch out like a butterfly into a different type of an entity, but still an orb, just larger with more features like limbs and, you know, different limbs, larger eyes, larger brain. They have no wings. The way they fly is they have a membrane which vibrates really fast, and that vibration causes anti-gravity because it's super fast vibration, and just the undulating of the membrane at such a fast rate creates an anti-gravity field due to electromagnetic energy that they all have. And they also have a positive and a negative pole. So when they reverse the pole, they can bounce themselves off the pull of the gravity, and by undulating that membrane, they make that amplified to the point where they can escape gravity. And here on Earth, that gives them the propulsion, and they're totally weightless. And by curving and slanting and shaping that membrane in different ways, that's how they make turns, go up, go down. That's the way they fly. It's not done, you know, using wings or anything, because they haven't got any. Now, we call them orbs, but they look nothing like orbs. They only look like that because they're moving so fast. And when that membrane comes out, it appears like it's a circle, but when they stretch their limbs out, that membrane is a hexahedron shape. And that's why there's a hexahedron shape in the stars. the smaller orbs go around the hexahedron because they need points to go around an equidistant, to make an equidistant circle, or, so it doesn't collapse on itself. So it's that hexahedron shape, and the way that's made is they stick their limbs out and open it up, and the 6 points of a hexagon is where the circles are going around each one of those 6 points, and that gives the orbs apart an equal distance from the center, if I'm making myself clear. So let's see the top. Okay, so they're moving from the bottom to the top. Let's see if they're clustering up on top. Yes, they are. Okay, so that's how they move from one cluster to another. It's like a flow. And it's constant. But it's the same orbs. So what they're doing is they're moving actually at a larger, making a larger radius or circumference, and moving right around that whole thing. And it's always counterclockwise. That also helps them escape the gravitational field by moving counterclockwise, because the Earth is moving counterclockwise as well. So they're staying in balance with the planet. Yet we're always being taught, be right-handed. Our clocks go clockwise, not counterclockwise. And we're doing exactly the opposite than what we need to do to be able to achieve, to be able to escape gravity. So even these little organisms are smarter than us. See, there's a lot of they swarm. See how they just swarmed there? That's what they do to whatever prey they have. They swarm it, just like bees. They'll swarm it. So there you have it. Okay, I'll go back to the original. And that's the little propeller, 6 inches in diameter. Okay, I use it to scare pigeons. So if you don't think you're breeding these things in and stuff like that, and they're not all over you, they're in everything and everyone, and yes, we're breeding them in. No doubt about it. They're so small. I mean, you need a microscope to see them, and this camera is better than a microscope. It's like having an electron microscope. So it's good for close-ups, and it's good for far, far away. Handy little instrument. And it's not that little, but at least it's not a huge telescope. Okay, one more time and then it's over. Let's see them. I see that ring right there. That's going to be a cluster. See, here's a number of little clusters forming, not just a single one. Now these can also blow, but they would have to spin a lot faster than that. Let's see what this looks like. Yeah, they're everywhere. There's a whole lot of little clusters on the whole thing. It's fascinating that these organisms can be this small and much, 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 much smaller, and then be stars. I mean, it's incredible. There's no level of size that they're not at, and no place that they're not at. Just goes to show you how different a same species can be, and how diversified and how functional and adaptive the same species, just different sizes. Well, I think that's it for the orbs tonight. I was going to do the moon again. That's the moon hologram I'm talking about. But tonight, the whole thing's lit up. And I won't be able to. It's so bright that there are no dark spots. The intensity has increased so much since last night. They must be watching YouTube. Okay, thank you for viewing, and have a good morning, because now it's, what time is it? It's 3:26 a.m. Thank you.